Good afternoon. The present research is part of the SUBSED Life project, which aims at demonstrating that it is possible to convert a waste into a supply, in this case a commercial substrate for nursery production, through the application of eco-friendly and green techniques. In this study, phytoremediated and land-farmed sediment was reused as plant substrate for the production of laurel plants. Millions of cubic meters of sediments are necessarily dredged annually from ports, harbors and waterways for enhancing commercial shipping and flood management. A big part of this volume is not inevitably a waste if properly decontaminated. Among the remediation technologies available today for sediment decontamination, phytoremediation and land farming have been previously proven to be successful in reducing the level of pollutants and increasing both physical and chemical fertility of the dredged material. So sediments dredged from Leghorn Port were subjected to phytoremediation for 3 years. Then the phytoremediated sediment underwent land farming, that is, periodical aeration by mechanical handling for 3 months before their use for plant cultivation, in order to promote biological activity and to reduce organic contamination. 3 types of standard substrates commonly used for ornamental and flowering crop cultivation in Tuscany were tested with different proportion of the treated sediment, that is 0, 25 and 50%. Standard substrate were the following: peat-based substrate, coconut fiber-based substrate, and wood fiber-based substrate, each one containing 40% of pumice. The substrates were used for the production of rooted cuttings of cherry laurel, Prunus lauroceratus cultivar novita, which is a typical and very diffuse evergreen ornamental with a very fast-growing and plant development. Nowadays, laurel is recognized as one of the most commercially important ornamental plant species for the Italian nursery sector. Here, under intensive growing conditions, this species is typically propagated by hardwood cuttings on a commercial substrate based on peat and pumice. Experiment setup was performed under greenhouse conditions. 2 different water regimes were applied in order to evaluate their effect on plant growth and productivity in relation to the substrate combinations tested. Water regime 1 was the water supply that plants usually receive under Tuscan climate conditions, equal to 480 cubic centimeters of water per day, and water regime 2 was reduced by 30%. Before and at the end of plant cycle, the substrates were characterized by a number of physical, biochemical and toxicological parameters. Moreover, laurel plant vegetative growth and various physiological parameters were monitored during plant life cycle, such as photosynthetic activity, chlorophyll content, lipid peroxidation, and heavy metal content. Let me start by giving you some background information on the pure sediment. Texture analysis showed a sandy loam structure. Bark density was over the limits set up by the LD75. The textural composition of the sediment resulted in a significantly lower porosity, water and air capacity, as well as easy available water compared to the control. Moreover, pH value denoted the alkaline condition of the sediment. Consequently, commercial substrate mixed with the treated sediment showed higher bulk density and pH as well when compared with the control. Total organic carbon and total nitrogen showed significantly higher values in control substrate compared to the sediment-based ones, owing to the organic nature of peat. In L3, TOC did not meet the limit of 4 grams per kilo fixed by the legislation regarding fertilizers. Conversely, the sediment-based substrate showed higher phosphorus values than peat. Considering the element concentration, higher values were scored for iron, copper, nickel, chromium, and lead, but all values were largely in compliance with the limits set up by the current legislation. The zinc values were particularly high and exceeding the contamination limit assessed as safe by the legislation regarding soil requirements in the substrate composed of 50% treated sediment. An increasing trend as the percentage of sediment increased was found for calcium, magnesium, and manganese. And interestingly, the sediment-based substrates showed concentration of potassium similar to those determined in peat. Finally, germination index always exceeded 60%, thus the tested sediment-based media are not to be considered toxic. Another analysis showed that the substrate type significantly influenced laurel growth except for base stem diameter. In particular, plant height, number of length of vegetative sprouts, and number of fully expanded leaves were strongly reduced when plants were cultivated on wood fiber-based substrate mixed with sediment. On the other hand, the applied water regimes did not affect the considered growth parameters. These differences were particularly evident in the first months of growth, but with time they almost disappeared. This was probably attributable to the fact that in pots, laurel roots tend to fill up rapidly all the viable space. That is why especially evergreen, fast-growing species cease to develop after 2 years in pot. Also, as regards leaf blade color, significant differences were found soon after planting, with leaves of laurel cuttings being characterized by higher brightness and chroma index when grown on mixtures containing wood fiber, regardless of the sediment percentage used. These differences then drastically decrease with plant development. The subset composition had a clear effect on plant dry weight and total leaf area measured at the end of the first growing season. In fact, such parameters exhibited a substantial decrease, even up to 40%, when wood fiber was included in the growing substrate, thus suggesting that the sediment itself did not represent a stress factor for the plants. Chlorophyll and carotenoids content, as well as lipid peroxidation in leaf tissue, which were used to test plant stress, did not significantly differ regardless of both the substrate composition and water regime used. Turning our attention now to the analysis of heavy metals in laurel leaves, we found that cadmium, nickel, and lead were absent. High manganese values were probably due to the low pH of peat, which favored its uptake by plants. Copper showed very similar concentrations in leaves obtained on sediment-based substrates and peat, except for those containing wood. A very different behavior was observed for manganese, which showed higher concentration in control leaves. These results might be ascribed to the alkaline pH value of sediment, which is the key factor in attenuating metal availability by precipitation of poorly soluble salts, such as carbonates and hydroxides. The most abundant minerals were potassium, calcium, magnesium, and phosphorus. Considering the effect of the growing media, phosphorus concentration was found significantly higher in leaves cultivated in peat substrates. This result can be explained considering that phosphorus availability in the sediment-based media is limited by the combination of high pH and calcium concentration, which promotes phosphorus precipitation. In conclusion, let me sum up the main points. Except for mixed trees, sediment-based media mixtures showed physiochemical parameters and heavy metal content in line with the Italian regulation for agronomic substrate for mixed growing media. Findings regarding nutritional elements highlighted the potential suitability of the sediment as an agronomic substrate. Moreover, results supported the possibility to use the phytoremediated sediment for the cultivation of laurel, since plants grew well in all tested substrates with the only exception of those containing 50 up to 75% of wood substrate. Reasons for bad testing performance might result from the physical properties of the wood matrix. For example, could be related to a quick drainage of surplus water that under container conditions might be critical since directly related to irrigation and therefore to plant growth. Otherwise could be related to nitrogen immobilization phenomena and therefore to a reduction in the availability of this nutritional element for plant. Finally, although sediment-based substrates were rich in zinc, this element was found at very low concentrations in the plants. Thank you very much for your attention.